In this video, we're going to talk about when a line is tangent to a circle and how to deal with problems when they've said a line is tangent to a circle. Now, what is a tangent? That's the main question here, right? A tangent is a line that only touches the graph at one point and no other point as well, right? So for example, if I have this circle, right? And I tell you that a line is tangent to that circle, right? So that means maybe let's say this line over here, if it's tangent to the circle, it just touches it at one point and that's it, right? In the previous video, we talked about 2 points of intersection. So maybe those look like this. We have two distinct points of intersection where the line crosses the circle. But in this case, if we're dealing with tangents, it means we're dealing with cases where there is one point of intersection between the circle and the line. So let's just write that as a note. So tangent, this means you have one point of intersection between your line and your circle. Right. So if we're dealing with intersections, what that means is we're going to take our two functions, the functions that we've been given, which is the function of the circle. So in this case, we're going to use actual examples here, right? So I'm going to give you a circle which has the equation x minus 2 squared plus y squared is equal to 2. So this is the same example that we used for the two distinct points of intersection video. But now we're going to have a different line, right? So our line in this case is going to be y is equal to negative x, right? So if you're given two functions and you're told to find the point of intersection between these two functions, a point of intersection means it is the point where the two graphs meet. If they meet, it means at that very same point, they have the same y and they have the same x's, right? Which means that we can interchange the y's and the x's between the two functions and between the two equations, right? So that means we use simultaneous equation to solve for the x's and y's where the two functions are exactly the same. So we can take this y expression, substitute it into there to join the two functions as one. So I'm going to take that, and then this equation is going to become x minus 2 all squared plus, now instead of having y, right, because remember we said we're substituting, so your negative x replaces y. So this negative x is now being squared instead of having y squared, right? So that's equal to positive 2. And then we simplify our expression. So this becomes x, right? So just to find the square of this, it becomes x squared. Negative 2 times x gives you negative 2x. And then that appears twice, so that becomes negative 4x. Negative 2 squared is positive 4 plus negative x. Remember the negative is also being squared, so that becomes positive x squared. That's equal to 2. And then we're going to simplify our expression. So we're going to take our x's, right? So we're going to take this, our x squareds, and this, that becomes 2x squared. We're going to take our x expressions. So we're going to have this expression over here, and that's the only one, right? So that stays as negative 4x. And then we have our constants. Our constants are going to be this 4, and then that negative positive 2 is going to become negative 2 since it's crossing the equal sign. So we're going to have positive 2 minus 2. That gives you positive 2. That's equal to 0, right? So now we have a quadratic, right? We can actually simplify this a little bit further. We can divide each term by 2. So the first term, your 2's cancel, that becomes x squared. For your second term, your 2 goes into 4 twice, so that becomes negative 2x. And then over here, your 2's cancel and it becomes positive 1. So that's equal to 0. Right, so we have this expression, right? And again, when it comes to a circle and a line, once you merge the two, you're always going to get a quadratic equation. It might not have all terms, so some of them might be 0, but the result of finding simultaneous equations between a line and a circle is that you're now going to end up with a quadratic. Whether it's a quadratic in terms of x, a quadratic in terms of y, it's still going to end up as a quadratic equation. So every quadratic equation has an a expression a B value and a C value. In this case, our A is 1, our B is -2, our C is +1, right? And then we're going to use these for our formula, right? Because in order for us to solve x, we say -b plus minus the square root of b squared minus 4ac, right? Divide this by 2a. So now all we need to do is plug in our values, right? Our a, our b, our c. So in order for us to solve for x, we're saying this is equal to -b is -2 plus minus the square root of b squared is -2 squared minus 4 times your a value is 1, your c value is +1, all squared divided by 2 times 1 is just 2. So we'll leave it like that. Let's simplify this so that the next point I'm about to make can make a little bit more sense, right? That's going to be x is equal to this, right? So -2, -2, that's 2 negatives, that gives you +2, plus minus the square root of. Now, if you put this into your calculator, right, this is going to be -2 squared is 4, minus 4 times 1 times 1 is 4. So that's going to give you 4 minus 4. This actually gives you 0. And then you divide it by 2, right? Okay, so we said for quadratic equations, in order for us to solve the quadratic formula, we can solve when this is positive and for when that's negative. So when it's positive, it's going to give us 2 plus the square root of 0 is just 0. So that's 2 plus 0 over 2, which gives you 1. Or we can solve for it when it's negative, when that sign is negative. So it becomes 2 minus the square root of 0, again is 0. And then you divide it by 2. So that's going to give you 2 divided by 2, which again is 1. So because this term that was in the bracket, in the square root, was 0, we actually got the same term. It just repeated itself, right? It appeared twice. So if your determinant, which we said we denote the determinant by this sign over here, if your determinant is equal to 0, in quadratics we say the roots have repeated, right? We have repeated roots, but essentially it means we have one solution. And if we have one solution, and that solution means, remember what we're trying to do in this case is we're trying to find the point of intersection. So if we have one solution to that equation, it means we only have one point of intersection. So you can actually just substitute this x value. This is the only x value that you have because it only crosses at one point. So that one point has one x value. So you can take that x value in order for you to find the y equation. You can just put it into here to get the y expression. But the whole point of this is to say, okay, when you are dealing with tangents, right? When you're dealing with tangents, it means your determinant is going to be equal to 0, but it's the determinant of what? Remember, this is going to be the determinant of the quadratic that you get when you merge your the quadratic from joining your circle and line equations. Okay, so essentially get your take your circle and your line, combine them because we're trying to solve for them simultaneously, and then from that resultant quadratic, which is this one over here, we then analyze the determinant, and we're saying that for a tangent, that determinant is going to be equal to 0. All right, hopefully that makes sense. Right, so before we end the video, right, I wanted to show you what this looks like graphically. So you can use this website is perfect, right? So it's called desmos.com, desmos.com, and then you can just look for the graphical calculator, right? So essentially it allows you to put in the different formulas that you have, and I've put in the circle that we were dealing with now and the line as well, just to show you that, okay, we have a circle, right? And we said we solve for x's, and then we got x is equal to 1, and it appeared twice. And we can see over here, this is that point of intersection. And the point of intersection has an x value of 1, a y value of -1, right? So, and that is a tangent. If this line had been different, let's say it's +1, you can see that it intersects at two distinct points. And if we had put this into our equation, it was going to give us two solutions. The determinant was going to be all different and all of that stuff. So if you want a visual aid to what we're actually doing, hopefully this kind of helps as well, just to show that, okay, it's not just numbers, it also appears on the graph. So, if that helps you, there you go. But this is even if you want to do your functions, whatever it is, you can use this website. It is perfect. But yeah, so essentially, this is how we deal with, if they say tangent, if they say one point of intersection, remember your determinant, once you combine these two formulas into one, the determinant for that resultant quadratic should be equal to 0. All right, so we'll look at some examples in future videos. But for now, hopefully, everything makes sense so far. I'll see you in the next video.